This is Note-Taking Guide 1.7, Properties of Rational and Irrational Numbers. Up here on the chart, we're going to show you what rational numbers and irrational numbers are. The main thing you're going to want to remember about a rational number is it can be written as a fraction, it has a repeating decimal point number, or it has a decimal point number that ends. Most of the time, if we remember those three things, we'll be able to tell if it's rational or irrational. Irrational numbers would be a number like the square root of 8, that when you put it on your calculator, it's a decimal point number that does not end and does not have a repeating pattern. Example of that would be pi. Again, irrational number would be a decimal point number that does not end and does not have a pattern. Alright, so let's look at this and see if we can decide which ones are rational and irrational. Well, -4 can be written as -4/1, so it can be written as a fraction. Anything that can be written as a fraction is going to be a rational number. The square root of 5, when you put that on a calculator, you get a decimal point number without end and with no pattern. So this is going to be irrational. 4/7 is a fraction, so we know it's rational. And the square root of 25, when you do that on your calculator, you get 5. 5 is a whole number, and we know whole numbers are rational. When we look at these examples of what we know to be the rules for rational and irrational numbers, if we're going to add two rational numbers together, their answer is going to be rational. Here's a couple examples over here for you to look at. 2 plus 5 equals 7. The square root of 16 plus 8 equals 12. That happens because the square root of 16 comes out as 4. So let's try an example of our own. How about 1/2 plus 1/2 equals 1. A rational plus a rational equals rational. The next rule says the product of rational numbers are rational. So if we multiply two rational numbers together, like we've done over here on these three examples, their answers are going to be rational. So again, we could do that with any other set of rational numbers, like 2 times the square root of 25. That would be 2 times 5, which is 10. The next rule says the sum, so when we add a rational and an irrational number together, it's irrational. I like to just remember that the minute you throw in any kind of irrational number, you're going to get an irrational number back out. So just kind of keep that back in mind, that if you put in an irrational number, you're going to get out an irrational number. The same thing on the product rule. If you have a rational and an irrational number, you're going to get an irrational number back out for your answer. So if you times the square root of 2 times the square root of 7, you're going to get the square root of 14, but that's still going to be irrational.